Alright, let's have a look at this wonderful DZVR, one of the first German armored vehicles of the late World War I or even the 1920s. There's a detailed look at it.
First, the basic specifications. The DZVR-21 had a total weight of 12 tons, a length of 5.95 metres, a width of 2.2 metres, and a height of 3.27 metres. It carried a crew of between 7 and 9 men and was protected by chrome-nickel steel armour ranging in thickness from 4 to 12 millimetres. Before we turn to this specific vehicle, let us first take a closer look at motorised vehicles and armoured cars in the German army from the early 1900s up to 1916. It was clear that the responsible authorities would seek to explore the potential of motor vehicles as combat platforms. Unarmoured automobiles, used in reconnaissance exercises before the First World War, performed remarkably well. Some covered distances of 200 to 300 kilometres in just 5 hours, achieving average speeds of more than 40 kilometres per hour. However, frequent technical failures, such as broken axles, damaged springs, and punctured tyres, led to the conclusion that they were too unreliable for frontline service. Experiments with armoured and armed automobiles, officially designated in Germany as Straßenpanzerkampfwagen, or road armoured fighting vehicles, were carried out by all major military powers before the First World War. Germany was no exception. These trials culminated in 1909 when a road tank unit took part in an exercise conducted by the 5th Guard Infantry Brigade in Neumark during the Kaiser's manoeuvres. The unit consisted of 2 French Charon armoured cars purchased by the War Ministry, a Mercedes armoured machine gun car, an unarmoured bussing machine gun carrier, and a command vehicle. The joint final report by the brigade, the Traffic Police Testing Department, and the Rifle Testing Commission emphasised the key advantage of armoured cars, their ability to cover long distances at high speed. This benefit, however, was offset by their limited cross-country mobility. Further trials and assignment to the cavalry were recommended. The Transport Troops Testing Department subsequently requested authorisation, together with the Rifle Testing Commission, to develop a road tank design that would incorporate the lessons learned. On the 12th of March 1910, however, the War Ministry decided, without taking these proposals into account, to abandon further trials. In doing so, it followed the recommendation from the General Inspectorate of Military Transport, which had concluded at the beginning of 1910 that armoured road vehicles were suited only to paved roads, while horses would remain indispensable for movement across rough terrain and unpaved routes. The potential applications of armoured road vehicles were therefore considered to be very limited. By the end of 1911, the General Inspectorate of Military Transport reached a final judgment. It determined that the armoured road vehicle was too technically vulnerable, its engine unreliable, and that adequate armour plating significantly reduced mobility under enemy fire. Heavy armoured vehicles became too slow and unwieldy on the battlefield, making them easy targets for enemy artillery, while lightly armoured vehicles offered insufficient protection. The von Lebel annual reports of 1911 summarised the official position with the following statement:
"The age of armour is over,"
as weight impairs speed without offering any real protection against fire. As a result, the existing vehicles were sold. Tests conducted abroad, such as in Austria and France, produced similar findings. For the same reasons as in Germany, attempts to introduce armoured cars were also abandoned in those countries. Nevertheless, a small number of armoured vehicles remained in France, Belgium, and Great Britain, having been provided to army authorities by industry for testing purposes. When war broke out in 1914, the German army entered the conflict without armoured vehicles. Troops quickly began adapting available passenger cars for combat roles. These vehicles were temporarily fitted with iron plates at the front and rear for protection. In this improvised form, often still largely unprotected, motor vehicles were used for combat reconnaissance, to transport machine guns to the front line, or even to intervene directly in the fighting. The appearance of isolated enemy armoured cars on the Western Front and their successful use in reconnaissance prompted the Supreme Army Command to demand on 22nd of October 1914 that the War Ministry develop its own road armoured vehicles. However, the shift to trench warfare in the West offered few opportunities for the effective use of armoured cars. At the same time, the automobile companies capable of building such vehicles were heavily engaged in producing army trucks, artillery tractors, weapons, and ammunition. As a result, only 15 armoured cars were built in Germany during the First World War, including captured and additional German-operated vehicles. A total of 32 armoured cars served on the German side, exclusively on the Eastern Front. From 1916 onward, the worsening shortage of horses and fodder accelerated the motorization of the German army. Armoured vehicles were often viewed as a mechanical counterpart to the cavalry, linking mobility and firepower in new ways. With this background in mind, let us now turn to the KDI, the underlying model of the DZVR-21 and the principal artillery truck of the German army. The basis for this armoured car was the Krupp-Daimler 100 horsepower KD1 artillery tractor, developed during the First World War for use by the artillery. At the outbreak of war, both light and heavy artillery still relied largely on horses for transport. Naturally, this imposed clear limitations on the weight of the guns, since horses can only pull a certain load. For the extremely heavy artillery pieces, railway transport had to be used. However, the importance of motor trucks for the army had already been recognised. As early as 1913, around 7,000 different trucks were available for military use. What remained problematic was their vulnerability and technical shortcomings, which required further development. In comparison, horses were still regarded as more reliable and consistent. Based on the operational experience gained in 1915, specific requirements for a practical artillery tractor were formulated. The weight and tractive power of the tractor were determined in accordance with the permissible axle load. At the end of 1915, Daimler received design specifications for artillery tractors from Krupp and submitted several proposals. At the same time, Krupp modified its 15cm cannon, originally intended for horse-drawn transport, into a gun suitable for motorized traction. When the new guns were ready, the first Krupp-Daimler 100 horsepower artillery motor tractor, designated KD1, was also completed. It was essential that the motorized tractor be capable of operating off-road. This required a powerful engine, wheels that would not sink too deeply into soft ground, and special wheel grippers to enable movement across rough terrain away from roads and prepared paths. The performance and overall design of the tractor were determined by the weight of the 15cm gun for which it was built. Gun and tractor were developed together according to the unified design principles. The maximum axle load of the gun ranged between 5.5 and 6 tons. According to principles established by Professor Rusenberger for the construction of motorized tractors, the tractor's weight was calculated at 1.25 times this axle load. As a result, the tractor weighed approximately 8 tons. A weight distribution ratio of 1:2 between the front and rear axles was chosen to ensure good maneuverability even on heavy ground. The first test drives took place in the Sauerland region near Winterberg, where the tractor performed exceptionally well. For difficult terrain, the wheels were fitted with grippers to improve traction. The first production order was placed in October 1916, with delivery scheduled to begin in May of 1917. The tractors were completed at the same time as the guns they were designed to tow. Of the 1,872 KD1 tractors ordered, around 900 were delivered before the end of the war. A total of 155 batteries of the 15cm Cannon 16 were equipped with this vehicle, including 25 fully motorized battalions with a total of 310 guns. Of these, 12 battalions, comprising 72 guns, did not reach the front before the war ended. The unit price of one artillery tractor was 59,000 marks, making it the first mass-produced artillery tractor in the German Empire. Manufacturing a single vehicle required 1,971 hours of labour. The success of the KD1, which was in high demand across the fronts, led in 1918 to orders for an increased number of tractors adapted for the Flak 19 anti-aircraft gun. These vehicles were designed to carry the Flak 19 directly on their platform and were designated KD-19. However, they were not completed before the end of the war. It thus became clear that this robust and capable truck provided an excellent basis for conversion into an armoured car. The armoured cars to be developed had to meet 16 specific requirements laid down by the VPK. First, the vehicle was to be armed with 3 machine guns, one of which would serve as a spare. 2 machine guns had to be capable of firing simultaneously in any direction. The ammunition supply was to total at least 16,500 rounds. The crew was initially set at 8 men, a commander, a driver, and 6 machine gun operators. This was later increased to 10 with the addition of 2 extra drivers. The vehicle had to be fully armoured, with a minimum armour thickness of 5.5mm excluding the roof. The combined minimum weight of crew, armour, armament and ammunition was not to exceed 2,500 kilograms. This calculation was broken down as follows: 2 machine guns at 75 kilograms, 660 kilograms of ammunition, 600 kilograms for the crew, and 1,000 kilograms of armour. Another key requirement was the ability to drive forward and backward at the same speed, without needing to turn the vehicle around. A rotating driver's seat position in the centre of the vehicle was specified, unless separate drivers were installed at the front and rear. The driver's observation slits had to be closable, and the driver's position was not to obstruct the machine gun operators. The vehicle was required to have 4-wheel drive, and the best possible off-road capability. To achieve this, it was to include a low gear ratio for difficult terrain, as well as carry wheel belts and ramps. The maximum speed was to range between 40 and 60 km per hour, both forwards and in reverse. The engine output had to be at least 40 horsepower, and sufficient cooling had to be ensured despite the enclosing armour plating. Steel wheels were required, preferably disc wheels rather than spoked steel wheels, fitted with rubber tyres and additional armoured protection. Finally, the vehicle was to be equipped at both front and rear with 2 acetylene headlamps, 1 movable electric searchlight, and electric lighting in the driver's compartment. With this list of requirements, the VPK approached the companies Bussing, Earnhardt, and Daimler. All 3 agreed to produce a prototype. Bussing developed the A5P, Daimler the Type 15, and Earnhardt, at its plants in Dusseldorf and Zella-Mellis, the Type E V4. When completed, the vehicles were to undergo factory testing and then be handed over to the Army in battle-ready condition. Due to time constraints, no initial crew training trials were conducted. Instead, the vehicles were assigned directly to a unit and sent to the front. The model that performed best in combat was expected to be selected for series production. However, by the time development was underway, the Western Front had turned into a static war of trenches. This significantly reduced the tactical value of armoured cars. As a result, priority was given to the production of trucks, artillery towing vehicles, infantry weapons, and ammunition. Consequently, progress on the 3 armoured car prototypes slowed. Finally, on 10th of December, the VPK reported to the Ministry of War that the Daimler 15, Earnhardt 15, and Bussing 15 had been completed and were ready for factory testing. Overall development and production had taken just over a year. The few vehicles initially produced had little impact on the Western Front, where trench warfare limited their usefulness. Moreover, they had been designed primarily for use on paved and unpaved roads. In the autumn of 1916, it was decided to combine the remaining vehicles into the Panzerkraftwagen MG Zug 1 machine gun armoured car platoon 1 and deploy them to the Romanian front with the Schmetto Cavalry Corps. There, where more mobile warfare was still possible, the vehicles proved their value in combat. Their success convinced the Supreme Army Command to order a larger number of armoured cars. Since Bussing and Daimler were already fully engaged in other wartime production, the new order was awarded exclusively to Earnhardt. The road armoured car was equipped with 3 or more MG08 machine guns mounted in a fixed turret. Although designed primarily for road use, it featured a reversible 6-speed gearbox, providing 6 forward and 6 reverse gears, as well as 4-wheel drive, twin tyres on the rear axle, and armoured mudguards. A radio system was initially planned, but it proved unsuitable in practice and was removed. The first 12 production vehicles formed machine gun armoured platoons 2, 3, 4, 5 and 6. Each platoon consisted of 2 EV4 vehicles along with the necessary support elements. Toward the end of 1917, a further 20 vehicles were ordered. These newly formed units were deployed with considerable success on the Romanian and Ukrainian fronts, and later also in Alsace on the Italian front. Some units supported the German Spring Offensive of 1918 on the Western Front, although they suffered significantly higher losses there. The first stage of development was the KDI, which we have already looked at. The main impetus for the start of production was the development and series production of the 100 horsepower Krupp-Daimler KD1 tractor. Before and during the First World War, and even after the armistice, German engineers and military personnel were fascinated by the idea of a single chassis that could serve multiple roles. It was envisioned as a load carrier, a base for anti-aircraft guns, a chassis for armoured vehicles, and simply as an artillery tractor. During the war, Earhart and Daimler developed all-wheel drive chassis primarily intended for anti-aircraft guns. However, these vehicles never achieved universal application. They were too complex, too weak as artillery tractors, and paradoxically too capable off-road to be ideal as armoured vehicles. In practice, their only truly successful role was as carriers for anti-aircraft guns. The situation changed with the introduction of Daimler's new KD1 artillery tractor. The chassis was stable enough to serve as the basis for an armoured car. It had sufficient power to move the heavy chassis and armour, while the large wheel diameter and four-wheel drive provided adequate manoeuvrability. However, the military demanded more than just four-wheel drive. They also required two driving stations, so the vehicle could move forward and backward at the same speed. In 1919, Daimler developed a new chassis based on the KD1 that met these military requirements. Using its previous experience with armoured vehicle design, the company proposed a new armoured car built on this platform. The first test configurations were mounted on this vehicle. These early versions can be distinguished from later types by their wheels of different heights. In the next step, the chassis was fundamentally redesigned. The resulting model, known as the DZR-19, received a steering system that allowed a driver in the rear to control the vehicle while reversing. A total of 40 of these vehicles were produced and delivered to various state police forces. Photographic documentation shows them in service in Baden, Bavaria, and Saxony. The vehicles were also loaned to the Reichswehr for military exercises. The design of the armoured car itself, reminiscent of German armoured cars and tanks of the First World War, was developed entirely in-house from front to rear. The combat compartment was divided into two zones. The front section, immediately behind the driver's cab, featured wide side wings. The rear, sloping sections were equipped with embrasures that allowed machine gun fire to the rear and to the sides. The large wheels, inherited from the KD1, were protected by armoured rims, which also reinforced the armour of the hull. At the rear, the armour narrowed and included a door with a firing hatch that also served as an evacuation point. The Type 19 featured an armoured superstructure with a single rotating turret mounted in the centre. This may represent one of the most important evolutionary steps in the development of German armoured cars. Compared to the later Type 21 vehicle, the Type 19 used significantly fewer angled armour plates. In general layout, it was roughly similar to the Earhart EV4 street armoured vehicle. The later Daimler Type 21 structure closely resembled that of Benz Type 21, of which 24 units were produced, and the Earhart Type 21, which saw 30 units built. These vehicles shared an almost identical armoured body, constructed from high-quality chrome-nickel steel. However, modifications were necessary to adapt the structure to each specific chassis. The underside of the vehicle was protected by 4mm thick armour plates, designed to shield the crew from hand grenades thrown beneath the vehicle. Operations in urban environments with short operational ranges required reinforced armour, which inevitably increased the vehicle's weight. Because the vehicle was intended primarily for use on paved roads, it was fitted with front and rear wheels of equal size and solid rubber tyres. With only a single steerable axle, drivers had to exercise particular caution when manoeuvring in reverse. The economic and political difficulties of the post-war period meant that these vehicles could only be delivered to state police forces starting around 1924. By 1918, the final year of the First World War, the production of armoured cars had largely been neglected. However, as armed unrest began to spread across the German Reich in the years that followed, law enforcement agencies saw a renewed need for such vehicles. To meet this demand, the Reich Army transferred around 50 street armoured cars to police organisations. Under the Draft Peace Treaty, German security forces were permitted to possess up to 150 of these vehicles. The ratified Treaty of Versailles, signed on June 28, 1919, prohibited the German Reich from owning or developing armoured combat vehicles with tracks, as well as wheeled armoured vehicles for the army. However, with the approval of the Inter-Allied Military Control Commission, armoured vehicles could be transferred to the protection and regulatory police forces of the German federal states. Under the treaty's terms, the Reich Army itself was allowed to possess 105 unarmed armoured personnel carriers. Most of these vehicles were scrapped in early 1939, as more modern and capable vehicles had become available. Of the 125 special police cars still in inventory in 1935, only 40 remained operational by 1938. One single vehicle survived until 1945. It was photographed heavily damaged in the inner courtyard of the former Berlin Reich Chancellery. There is actually some source material available, including moving pictures of several armoured cars. Although these films date from the period between 1919 and the early 1920s, they still show armoured cars that were originally developed during the First World War. The first vehicle driving into the frame is the bussing A5P. The A5P was a massive vehicle that used a double-ended layout, which at least provided tactically useful high ground clearance. Its power plant consisted of Bussing's successful six-cylinder truck engines. The vehicle had a large steel armoured body and was crewed by 10 men. 6 of the crew operated 3 7.92mm machine guns, usually the MG08 or MG15NA. In this footage, we can observe at least some members of the large crew entering the vehicle. Particularly interesting is the distinctive leather uniform worn by one of the suspected drivers. Some vehicles were even equipped with 2 Becker 20mm cannons. Production of the A5P began in 1916. However, the German army considered the Erhardt design to be more effective in fulfilling the required operational tasks. As a result, only one vehicle was produced. The A5P, together with several other armoured cars, served in a column on the Romanian front in 1916 and later on the Russian front in 1917. The next vehicle entering the frame appears to be a version of the 1917 Erhardt EV4. The Erhardt and Daimler designs were apparently very similar. Both placed the engine in the front, protected by armour, and featured a large, box-like body at the rear with a turret or cupola mounted on top. Both also had a rather clumsy appearance and were far too heavy to effectively fulfil the operational tasks demanded by the German army. Both the Daimler and Erhardt prototypes relied on double wheels on each side of the rear axle. At the front, they used single wheels fitted with flanges, an attempt to reduce ground pressure and improve the vehicle's cross-country mobility to a useful degree. This footage also demonstrates some of the capabilities of these armoured cars. We can see them driving in reverse and observe their manoeuvrability. It also shows a radio set, although in this case it was operated outside the vehicle. Armoured cars offered protection against bullets and shrapnel, but they were still highly vulnerable to artillery fire. Let us look at some footage from the film Men Without a Fatherland. The movie was produced in 1937 and it clearly contains elements of German propaganda. The story is set in Latvia at the end of the First World War, where a group of Freikorps fighters battle against an attempted takeover of the Baltic states by communist forces. In the scene, an armoured car approaches the German lines. After several attempts, an artillery shell lands near the vehicle, destroying one of its wheels as well as the engine. A second direct hit then blows it up, at least in the dramatic cinematic style of the time. As far as it can be judged, however, the portrayal is reasonably close to reality. The following footage is no longer from a movie, but consists of actual camera recordings taken after a battle. In these scenes, the armoured cars do not appear to have been hit by enemy fire. There are no visible signs of damage that would suggest that. Instead, it seems more likely that the vehicles simply became stuck and were abandoned by their crews. In the footage, we can see German soldiers inspecting the stranded vehicles. Now, let's take a closer look at the engine. The engine was a Daimler M1574 4-cylinder petrol engine with 100 horsepower. Hence the name of the artillery tractor, the Krupp-Daimler 100 HP artillery motor tractor. The engine had a displacement of 12 litres. To ensure optimum power transmission to the wheels, the tractor was equipped with four-wheel drive. The KDI was developed by Professor Ritz Rosenberger, a mathematician, engineer, university lecturer, weapons technician, and official in the arms industry. Before diving further into the engine, let's put the spotlight onto the developer himself, who was also behind the DZR19 and DZVR21. Fritz Rosenberger, also known as Friedrich Heinrich Rosenberger, was born on February 13, 1868, in Frankfurt am Main, and died on April 28, 1926 in Munich. he became a design engineer at Frederick Krupp AG in Essen, in the artillery equipment department under director Max Draeger. In 1901, he became assistant to the board of directors, and by 1904 he had been granted power of attorney. At the suggestion of Alfred von Schlieffen, Rosenberger began developing the Big Bertha in 1904, a project completed in 1914. Around 1905, he was appointed by the Prussian military authorities as a teacher and professor of weapons design at the new Military Technical Academy in Berlin-Charlottenburg, returning there briefly in 1906. In 1907, he became a deputy director, and in July 1910, after Draeger's departure and the division of the department, Rosenberger and Rudolf Hartwig were appointed directors. In the autumn of 1914, when the Supreme Army Command, OHL, was considering how to bombard the English port of Dover from the French Channel coast, they submitted a request to Krupp. Rosenberger proposed a low-drag shell. During initial tests in Meppen, the projectile flew farther than expected because the reduction in air resistance at high altitudes had not been accounted for. Together with his assistant Otto von Eberhard, he subsequently developed the Paris gun. After retiring in 1920, he was appointed to the supervisory board of Krupp AG the following year. He received honorary doctorates from both the University of Bonn and the Technical University of Karlsruhe in 1914, along with numerous German and international awards. Among other publications, he authored the standard work Theory of Recoilless Guns in 1907, which saw a second edition published in 1937. His research was widely cited internationally. Rosenberger therefore played an exceptional role in the development of German artillery, guns, and artillery tractors. Returning to the engine itself, 4-cylinder engines were common at the time, with cylinders arranged upright in a line, as we can clearly observe in the original. This footage shows a similar engine, also with 4 cylinders, though smaller in scale. The functionality, however, is the same. A mixture of petrol and air is injected into each cylinder, and the resulting force pushes the piston downward, setting the crankshaft in motion. The crankshaft, in turn, drives the wheels. The flywheel is set in motion to keep the engine running. Essentially, it works like modern engines, though the layout may seem unusual to today's eyes. Looking under the armoured car, we can see the steel wheel suspensions on the sides. We can also observe the 4-wheel drive in action, at least partially, along the wheel suspensions. On top, the DZVR-21 featured 2 turrets, each mounted with an MG08. The driver's viewing slit was armoured, but could be folded outward. There were also several embrasures for guns and pistols around the vehicle, which could be opened or closed to minimise weak points and reduce blind spots. This allowed the crew not only to maintain a better overall view, but also to cover angles that the machine guns could not reach, or to engage attackers who came too close to the vehicle. In summary, the development of vehicles like the DZVR-21 reflects a wider story of trial, adaptation, and compromise in early 20th century warfare. Before the First World War, armoured cars had already been tested, however they were largely dismissed. Technical limitations, poor off-road mobility, and the belief that armour slowed vehicles without offering enough protection all contributed to this scepticism. Yet, these assumptions proved only partly correct. With the outbreak of war, the German army was forced to improvise, reconsidering motorised combat vehicles under the harsh realities of the battlefield. Wartime experience revealed a clear contrast. On the Western Front, dominated by static trench warfare, armoured cars had little impact, but in the East, where fighting was far more fluid, they demonstrated real potential. In these environments, mobility became a decisive advantage. At the same time, a growing shortage of horses, combined with the increasing logistical demands, accelerated the shift towards motorization. Vehicles began to take on roles that had once belonged to cavalry. Built on the proven Krupp-Daimler KD1 artillery tractor, the DZVR-21 represents the culmination of these developments. Its design combined a strong, reliable chassis with armour, multiple machine guns, and advanced features for its time, such as 4-wheel drive and the ability to move forwards and backwards at equal speed. However, it was not without its drawbacks. Like earlier designs, it faced challenges including heavy weight, mechanical complexity, and vulnerability to artillery fire. Ultimately, the DZVR-21 was not a final solution, but part of an ongoing evolution. It illustrates how technological innovation, battlefield experience, and practical limitations all shaped military development during and after the war. Following the conflict, many of these vehicles were transferred to police forces, while restrictions imposed by the Treaty of Versailles further influenced their use. Taken together, they represent a transitional moment in military history, where traditional concepts and new mechanical technologies coexisted, a period that marked the gradual yet decisive shift toward fully motorized warfare.
Alright, thank you all for watching, have a good one, and see you next time.